We've just seen how with noisy instruments, it can be hard to detect subtle phenomena, like adding a grain of rice to this noisy scale. Now, with very powerful instruments, we can detect extremely subtle phenomena, right? So if I took that grain of rice to, the labs around the University of Michigan, you bet we would be able to detect that it, it has some, weight. Now, there are many instruments outside of a lab, right? Remember that a survey is also an instrument. And the more people you have in your survey or poll, the less noise there's going to be in your outcomes, right? So the closer you get to getting everybody in the population in, the less variability is there's going to be from sample to sample. So if you study a lot of people, it's analogous to upgrading your scale. And suddenly you can detect even very tiny differences in outcomes. What does that look like? Okay, so we're going to go back to a very large study that was in the news, and you might remember this from part one. This headline said drinking very hot tea almost doubles risk of cancer. And in part one, we explored some issues with the way this study is presented in the news, that even though, it might be a very interesting study from a public health perspective, it is not necessarily a guidance for, the people that read the newspaper that this is published in. Now, in this study, the study that is behind the headline, it's actually quite a large study. There's about 50,000 people in the study, which is really impressive, right? So whenever you run something that large, it takes in a tremendous amount of coordination and dedication. A lot of admiration for the study authors here. Now, the actual numbers in how people differed in, cancer rates. So in this group of people, the authors divided them up into two groups: people who reported drinking very hot tea and people who didn't, people who drink cooler tea. And remember, this is people in Iran. And, I don't know this firsthand, but it sounds like from the paper there's a culture of drinking, tea drinking, and some people really prefer to drink it quite hot. And so the authors of the study then looked at about how common was cancer in each of these groups. And we found that in, 80 in 10,000 people among the very hot tea drinkers, went on to develop cancer. And 57 of the cool tea drinkers per every 10,000 went on to develop cancer. Now, this difference, although it might be, important for scientists to know about, it's in practical terms, it's kind of modest, right? This isn't a huge difference between the two groups, right? So not saying it's not important to know about, but it's also not an overwhelming or dramatic difference, right? It's kind of modest. And so this number here, the fact that we're able to determine that there is this difference is likely possible because our study is just so big, right? So with 50,000 people, it becomes possible to detect a difference like this, and that this sort of difference will be statistically significant. Now, what do we do with this? That's a question that I can't answer by looking at this because I don't really understand this, the public health stakes of this. But I could imagine somebody who, works on cancer prevention in the public, looking at this and trying to weigh the costs and benefits, looking at, okay, considering how many extra deaths might be attributable to the hot tea drinking versus, what are the costs if we were to try to intervene? What other health priorities would we have to, defund or not contribute to if we were to try to make this like a campaign to change how people drink tea or raise awareness about it, right? Because in practical terms, every time you want to go after one problem, you'll often, there's going to be some trade-off or cost about what other problems you can pursue. And are there any benefits of tea drinking? If the very hot tea drinkers were going to stop drinking tea, perhaps because of they like it very hot, and if they can't have that, they don't really want it, right? Then they would be losing other benefits that are associated with the tea. So is that worth the trade-off in lives we might save by preventing this? So I don't know the answers to any of that. My point is here, it's not obvious to me from looking at this that this difference, necessarily should be the basis for a public health campaign. Another example is a study on cold sore medication. So this is another real study, and in this study, a team enrolled about 2,000 patients. Cold sores are kind of a nuisance that can occur around people's lips a lot. It's very common in the population, but they're painful and they're annoying, and they do spread sometimes. So in this group, they were assigning an experimental medication to the study. And so what they say is that healing of lesions in the treatment group occurred in a median of 4.8 days versus 5.5 days in the placebo group. This result was statistically significant. To unpack what this means, they took people, the 2,000 people in this study, they split them into two groups. Some of them got a placebo, a medication that doesn't do anything, and some of them got the real medication that is being studied. And so, the group that has the real medication got better in a median of 4.8 days. And the group that didn't, that got the placebo, got better in a median of 5.5 days. And that difference is statistically significant here. Now, the real question is this benefit meaningful to patients, right? So are they happy with, this sort of reduction? Because it looks like it's about 3/4 of a day. And as some other scientists pointed out in this paper that I'm citing here, this difference of 3/4 of a day improvement time is probably only detectable because of the study is so large, right? You wouldn't get this. You wouldn't be able to detect this sort of difference with a much smaller study. And so even though it's statistically significant, that's not necessarily interesting to doctors because we would have to know, do patients actually appreciate, that much improvement relative to the costs of having to take a medication, right? Every medication comes with some side effects and some risks. So would they choose to accept those risks and side effects relative to the benefit? And so is it clinically useful? Is here maybe quite distant from the question of, is it statistically significant? This is an example of how a study can be overpowered, right? So before we were talking about underpowered, when you really don't have the right tools to detect a very subtle phenomena. Here we're talking about if you have, really, really powerful equipment or a really powerful study, meaning it's got a lot of people in it, you can begin to detect very, very small phenomena. So in this case, where we're talking about things with people in them, like a survey or a poll or a clinical trial or a study in a lab, the more people you have, the more subtle the sort of differences and phenomena we can begin to detect with statistical significance. And so that means that particularly as we move towards, these very powerful studies with lots of people, significance isn't the same as practical importance. So to return to the mayoral race example, even if we're reasonably confident that Melvin gained some votes, that's maybe not the question we're after. We don't actually know, care, did he gain votes or not? We actually care about how many he gained a lot of the time. And so what we really want to know is how big or small could that number plausibly be, right? We want to know something like, is his gain between 5 and 15 percentage points? Or is it, another way to say that instead of in, percentage points might be an absolute number of votes. How many votes did he gain, right? So I'm just making up these numbers as examples of how it might look to answer this question. But what we really want to know is, how what's the scale of his gains? Is it a lot or is it a little? And the size of the poll affects what kind of changes we can detect, right? So if we have a very tiny poll, then we could only detect very dramatic swings in Melvin's polling. But if we had a huge poll, we could detect even unimportant changes, right? So we might say, oh, if we have a poll of like, thousands of people or animals in Melvin's town, right? Then maybe we could detect changes that are on the scale of like a fraction of a percentage point. And while that is real and it is a gain, it's not necessarily an important gain for Melvin and his strategists to know about. So now that we've talked about all this, let's return to this question. Should Melvin double down on his egg strategy, knowing that, his gain in the poll appears to be significant? What do you think? Okay, well, unfortunately, the answer here is I still don't know. And, the significance testing and the hypothesis rate, that might be an important part of the evidence that his team would use, but he's gonna have to, put that together with a couple of different other pieces of information. Like, we'd want to know, was the poll valid? Is there any reason to doubt the validity of the poll? Like, what if we found out that the poll was not doing a good job randomizing who gets in, and it actually represents only a very small and unrepresentative segment of his town, right? That might be suspect. What would be the costs of doubling down on the egg strategy, right? Like, how can he actually afford to keep doing this? Are there any other explanations, right? Like, we haven't gone into the causal angle here at all. We just know that in the latest poll, there appears to be a real difference in how Melvin is polling from before, but that doesn't tell us why. Maybe his competitor has gone through some sort of dramatic scandal, and so it's not that people like Melvin's egg strategy, but maybe that accounts for it. Or maybe, late in the game, maybe people just start responding to polls differently than before. No idea. But we really have to consider, are there any other possible explanations here? And there's plenty other, right? Practical importance. Is the gain that he's seeing, big enough to matter? Um, can Melvin even handle this many eggs? Maybe this is just too many eggs and he can't produce this many eggs. There's no way. If he doubles down on this strategy, it's going to be at the expense of other strategies that his team could be pursuing. And finally, there might be firsthand experience here. Like, maybe Melvin has just received some information about how the landscape in the race is going to change, and it's important that he pivot now to focus on something else based on breaking news, right? So I'm not trying to say that, this hypothesis testing doesn't matter at all, but it's that it has to be a bigger part of, our understanding of an issue. It's really on its own. It's never enough. It's a part of our strategy for understanding what's going on. So, it's often, I think sometimes hypothesis testing is phrased as or presented as the answer to the questions that we're seeking in science or in polling. But it's often really one of the first questions, and then it leads us to other questions after that. So, a final thought here, based on everything that we've seen in the last couple lessons. What do you think significance is a property of in our mayoral race example? Is significance a property of Melvin's popularity, or is it a property of a lot of things, like his real popularity, the polling method, the threshold of significance we used in our test, the number of voters in the poll, the way voters were selected to participate in the poll, et cetera, et cetera? What do you think? Well, it's all of those. It's all those things. And it's that significance only has meaning in context. It's not a description about Melvin or his real popularity. It's a description of all of the things that we did to take our measurements and how we analyzed our data and how we asked our question and how we set up our tests, right? Significance has meaning in this context. So in this context of, what we did, we found something significant.